So today I'm going to be going over best practices in DPA, high-level monitoring with using DPA for your databases, and then also creating some example alerts for said data. I'm going to go ahead and share my screen. So right here, I've got our database demo site. We can send that link in the chat for people to follow along if they'd like. So this is just an example DPA demo that's out there for folks to access. You can just sign in with the predefined credentials that are already there. I'm going to go ahead and drill into a Orion database. We've got our home page here for DPA that just kind of shows you your overall main advisors, we call them, and they have different categories within them. So there's wait advice, tuning advice, CPU, memory disk, sessions. They're all different kind of categories. If we drill into a database, we've got some of those same tabs that are available on the top. You can also click on the resources tab and those become available. DPA, DPA monitors data based on weight-based analysis. So we're pretty much running queries against the monitored instance to determine what queries are currently active on the monitored database. You can drill in to get data that's very specific within DPA, so you can keep drilling into these dimensions or time slices by clicking the various areas in the product, like the time slices here, or you can even click on the drop downs here. Once you're within an hour time frame, usually what we like to do is click on the big bar because that's like the highest weight activity for that time range. So for example, if I click on this big bar right here, that'll take me into an hour time frame. So I'm in an 11 a.m. to 12 p.m. time frame on November 12th on this database. So you can also see kind of where you're at on the top to kind of help navigate. Once you're in there, you can look at these different dimension tabs that we have available to determine if there's a specific user that's executing a lot of queries against the database or other things like that. And then you can even filter activity to that particular user by drilling into that user. And then you can see on the top breadcrumbs that we're actually drilled into activity specific to that particular user now. So once you're in there, you can even filter out to do analysis of SQL statements where you can get information about that particular query, like what kind of plan it was using, other information like that. So if you scroll through this, you can see that this particular query was using one SQL plan. If you want, you can drill into that particular plan and get the plan information. That can sometimes be helpful. Let's go ahead and go back to the home page. So when we're back to that instance page, there's also other dimensions that only become available when you're into a specific hour time frame. So when I'm scrolling down here, there's certain tabs that are available, like for example, this blocking tab, which can show you what overall blocking was happening throughout the last 30 days on this particular instance. So we can see, hey, there was a pretty large blocking event that happened on November 7th here. So we can drill into that November 7th date and then scroll down again, click into this blocking tab and see when that blocking was happening throughout the day. You can then drill into that hour time frame and a new tab will appear in DPA for you to be able to get information, like specific information about that blocking event that happened. So if I click into that blockers tab, you can see the information about the SPID that caused that blocking event, how much time it caused blocking, what program caused the blocking. You can even get the machine name that called it. So potentially maybe there was this was the SA user by some like Java particular process, but you can get the details of that particular query by clicking the details and see that this looks like it's actually an Orion query that's causing some problems potentially. It might not be a problem. It might just be expected behavior. Again, blocking is expected in certain scenarios. But you can also get information about what queries were victims for that blocking query to see if there was potentially a problem with, or one of your users was impacted by that blocking query. This is also available by going to the current tab. And I'll actually show you an example of that in my own test environment in a sec here. But one other example that I wanted to show of things that you can do to correlate information in DPA, just from a high level view, is if you if your databases are running on virtual machines, then there's an additional monitoring capability with DPA that you can detect certain events that have happened, like vMotions to other hosts, so you can correlate that information to potential problems that maybe happened. For example, we'll automatically annotate events like this where a VM vMotioned from one host to another, and that could correlate with other spikes in activity that you could potentially see on these weight bars up here. So that can be pretty helpful for just kind of correlating specific events that could have happened where users had to wait for a long time for something, or there was some problem that was brought up. Another area that we automatically annotate events that can be helpful is if you're running an availability group. So we automatically annotate AG failover events as well. So that can potentially help indicate if there's some kind of performance issue or something on a database that can help indicate that was maybe the problem, that it failed over to another host and there was maybe some networking hiccups or something going on there, or something to look into on the AG side. The next thing I'm going to be showing is some examples of how we can alert on said data. So I'm going to go ahead and pull up my own test environment here because we cannot create an alert in that lab. So I've got my test environment here, and got a database that I've been working with. So as we can see here, when we talk about looking at the big bar for DPA, this is a good example of we've got basically no activity being shown throughout these days here, but then on today, there's a huge spike. So what you can maybe look at there is, hey, was there any blocking going on? Well, if I click the blocking tab, we can see that there was a large amount of blocking activity. You can also even click into the current tab while you're in the database to see if there's currently blocking happening. And in this case, I have 5 active sessions, and I also have 5 blocked sessions. So I can click into this show blocked sessions resource here, and I can see the blocking chain of what's happening. And the reason why these particular queries are waiting is because there's a query here that has a wait for. I kind of intentionally created some blocking in my test environment to just show an example here. So these queries are actually just waiting for my wait for query to complete on the top here. So, and again, it indicates that the queries that's blocking is coming from SQL Server Management Studio. So that could indicate hey, maybe you have an end user that has some query stuck open in SQL Management Studio that they need to kill. So that can be relatively helpful for that. As far as creating alerts for, let's continue on that blocking train. So if I go into the resources tab while I'm drilled into an instance, there's different categories that we can look at for different resources, and there's a sessions category, and we can see here that my blocked sessions are currently in the critical category or critical threshold. You can adjust thresholds for said alerting objects by clicking that little slider button there, and you can set your thresholds accordingly. That'll be helpful for creating your alerts for sending emails to people when you maybe have an event that you want to notify your DBA team or other people that maybe are responsible for that server when you have a problem. So in this case, I'm going to go ahead and go to the alerts button up here, and I'm going to go to manage alerts. And then for the alert category, we'll select the resources bubble. And for my alert type, we're going to pick a single resource metric. So for this, I'm going to just call it block sessions alert. And then just give it a quick notification text to send with the email. The execution interval for the alert, that can be important to look at because the execution interval for a resource alert is dependent on the sampling frequency of the metric that we're gathering. So if we go back to that database and go to the resources tab, go to that sessions, we can see that we're sampling and gathering block sessions for this database every minute. So when we go back to the alert, the percent, how this works is it's basically looking at, if we pick a category here, then block sessions, this is looking at the percentage of the metric that's meeting that alarm criteria. So right now it's set to 75%. So if I have an execution interval of 10 minutes, every time this alert executes, it's going to look back the last 10 minutes for what percentage of the metric met this criteria. So if this particular metric is sampling every minute, then we're going to be looking back 10 minutes and we're going to get 10 data points. So this would mean that 75% of those data points need to be in a warning or a critical state for the alert to trigger. That can help eliminate false positives if you don't want to have, if you only want to have where at least 50% of those polls, so 5 out of the 10 polls that we sampled for block sessions indicated warning or critical values, then send an alarm. So this can be important to set both a combination of the execution interval as well as the percentage value that you have set there. So if I go ahead and set an example user there and then test my alert against my database instance that I had those block sessions on, I can see here that all of my data values that were pulled in the last 10 minutes were in a critical state. So this alert would actually be sending as a high alert value. I could, if I adjust this alert interval to 10 hours, for example, there may not have been as much blocking happening in the last 10 hours. So if I test that, we see that only 16% of our polls within the last 10 hours were in a warning or critical state. So the alert would not have triggered. So it's very important to look at what your execution interval is versus the percentage values, but that can also help eliminate a lot of false positive alerts that your DBAs might not want to get. So that's a more basic resource alert example. I'm going to go ahead and now show an example of a custom SQL alert. So this custom SQL alert is actually from our Slack community. If we go to manage alerts and then custom, you can select a bunch of different options here, but we're going to go ahead and do custom SQL alert multiple numeric return. What this allows is to return one or more name numeric pairs. So you can return a value that has a name in the first column and then a statistic in the second column. This particular alert that I'm going to show an example for today is going to be file size or drive size. So we'll just call it drive size test. This is the current drive. This is actually going to fetch information about each hard drive on the particular SQL server because it's not a metric that we gather by default on DPA. So sometimes customers will ask like, hey, how do we gather this info in this product for something that you don't gather out of the box? So you can actually kind of use this alert as a metric as you will. You can also gather metrics in DPA, but for this example, I'm going to be showing an alert. What we have to do here now is enter a SQL statement that returns a string in the first column and then a numeric in the second column. So again, I got this particular example from our Slack community. And it basically is creating a temp table and then getting information using a stored procedure. I did have to enable some additional settings on the SQL server to allow this stored procedure to execute properly. But you could use this. This is kind of just an example that shows that you can gather multiple metrics against databases. So we're going to put gigabytes there, and I'm going to set a value here for the thresholds. In this case, this is the free space on the database. So I'm going to actually set a threshold for this to be anytime the value is 0, between 0 and 5. So that's going to tell me whenever the database is under 5% capacity, between 5 and 0. In other situations, if you're, let's say, looking at a value like that, the total space of a drive or something like that, and you want to make sure that you're alarming whenever it doesn't go beyond a value, you can leave the max empty, because that if you put a value in there, that could potentially prevent you from getting an alert if it goes above that value. But in this case, we're looking at things that are lower value because we're looking at like the free space on a drive. For this, then we can do between 5 and I'm going to do 30. And again, I'll just select myself for a contact, and I'm going to go ahead and test the alert. So we can see here that this will return multiple columns, and each column that is returned is analyzed individually as its own alert object. So we can see that my E drive has less than 30 gigs available, but my other drives are good. And that will flag that as a medium. So in this case, if I actually submitted this alert through, then I would get an email because I set myself as a contact for that medium threshold. So once you've created those alerts, I'm going to just show you an example, one that I have created here. You can go to the alert status tab, and I see that I already have a % free disk alert that I created. That was the same one that I was showing you an example of just now. But I've had this out there for a few hours now. So as an example of this, if you click the history button, you can actually see every time that alert pulled. So I had this alert set to gather essentially this disk information, the free disk space, every 10 minutes. So if I want to see a historical information about what the disk usage was at that time, I can just click here, and then you can compare what those values were at certain times or see why that might have flagged the overall alert as a low. So in this case, we can see the reason why the alert is flagged in a low status is because this particular drive has hit that threshold. Another area that people will want to use in DPA to kind of pat themselves on the back, let's say, because DPA is really used for weight-based analysis, where it shows you the most poorly performing queries first, and then other ones aren't showing. So if you have a really crazy query that you don't want to be showing on these charts, like let's say, for example, I don't have control over this query, or we know that this was some user that kept SQL Server Management Studio open on a committed query, that you want to exclude that. So you can click into that particular query and then click the button up here. If you uncheck the show in trend charts, then save it. You can go back and we can see a lot more useful information that I can actually potentially action on this database for data that that query wasn't actually doing. So if you want to bring it back, there's this View Excluded SQL button to bring it back in. On that same topic, if we click the View Excluded SQL and then re-include it, if we look at that text, let's say I want to just if we fix that query or fix the problem with it, and you want to search for it, you can click the Reports button on the top, and then click Top SQLs. If you click Report Options, then you can click this User Defined SQL Statements bubble. Click the Add button, and then search for that search string. So if I just search for update and then click the SQL text button here, I can search for any queries that had an update in them and find them in order of the most weight to the least weight. So we can see that we had this update running and it had 7 hours of wait versus the next most problematic update, which was only 7 minutes. So in this case, I already know that this is probably the one that I'm trying to focus on. I can click OK on that. And then if you click Display Report, that'll bring you into that query information, and you can go to the query analysis and get more info about what that query was potentially doing, see if it's using some new plan, if it was being blocked by something else. Just kind of use that information to help with whatever you're looking for. Either that, or you could go the opposite direction, where if previously DPA saw it as a problematic query, but it no longer sees it as a problematic query, what it'll be an easier way for you to show that, yeah, this has now improved a lot and it's no longer showing weight. So yeah, those are the main areas that I would say are pretty helpful for that. Does anybody have any questions for me? No, I talked relatively quick there, so I'll kind of try and re-summarize what I had talked about. If we go back to the Orion demo site here, again, you can use different areas to correlate performance. So if you're in a VM, you can use the virtualization tab that we have here and click into your instance and then see if there would be motion events that maybe cause certain things to happen. You can also, if it's running in an availability group, you can get information about if there were AG failovers that potentially happen automatically. You'll also just want to continue to drill into an hour time frame, because that gives you the most information and additional tabs, like the blockers tab that becomes available. It also allows you to filter into specific areas, like we showed, where you could filter into only show activity for a specific user. And then we also showed looking at these metrics, the sampling interval of the metrics, having alerts that go based off of the thresholds that you set on those metrics, and then also creating custom alerts. All right, so I'm going to go ahead and hand it on over to Dominique here, and he's going to show us some DPM related stuff. And yeah, thank you everyone for listening.
Thanks, Riggs. So yeah, my name's Dominique Flannery. I'm a former MySQL DBA for 10 years, and I'm now a customer success engineer at SolarWinds, working primarily on the DPM product. And let me go ahead and share my screen. All right, hopefully everybody can see my screen. So what this is, I'm going to be going through some of our internal apps to demonstrate the power of DPM. So this is the page that you would first see when you first log in. And as you can see up here, you can actually monitor and look at multiple different database types all at the same time. The first module I'm going to go into is going to be the profiler. And the profiler is one of the most important modules to use, especially proactively as well as reactively. And as you can see, since right now I have not filtered by any hosts, we can actually see intermingled MongoDB queries, MySQL queries, etc. If you're like me and more focused on MySQL, and you just want to focus on just the database hosts that relate to you, you can actually just select the type up here. There's also the option to use host tags to where you can filter by those as well. And I'm just going to stick with the MySQL type here. And so now what I'm looking at is only queries that relate to MySQL. And up here, you have the ability to select different time frames. I generally like to start by looking at, over the, an entire week. Count for weekends versus weekdays versus the evening hours, etc. And right now, we are looking at the top 50 queries, and we're looking at them by total time. And the reason why that's really useful is because you really want to understand which queries are spending time on the database. And that could be because they're ran very frequently, but have very low latency. They could be ran infrequently, but have higher latency. But it's important to understand what those queries are. So as you can see here, this top insert query actually accounts for 82% of the total query workload by total time. And it counts for a little over 32 days or almost 33 days of wall clock time over the last 7 days time frame that I'm looking at. A lot of times our customers that will chat in, with new issues, like let's say, all of a sudden CPU is increased, etc. There's a number of things that we look at immediately to identify to see if it's something like a new query, etc. So one of the easiest ways to do that is you can add in these different columns. And as you can see, there's lots of different columns that you can add in, like if you wanted to see queries that are missing indexes, etc. But in a reactive state, using this first scene is very useful. So if I just go and add that column in and then sort by it, now I can see, was there a new query that was introduced during that time frame when, let's say, CPU increased? And that can really get you a quick win to identify, okay, it's really this one query or this group of queries that came in from a new code deployment that are really accounting for that increase in CPU utilization. Let me remove that. All right, so next, one of the next things that we would look at if there's been an issue would be to be able to compare on different time ranges. So right now I'm looking at 7 days, and let's say I wanted to compare the previous week. And this can be useful proactively as well as reactively. This is one of the things we recommend to do after code deployments. Maybe look at, after the day after it's been deployed, looking at the previous day, or you can compare hour to hour, etc. And then what that does is that brings in this change column. So you can see, if there was any positive or negative change in that performance. What's important to note is whatever you're comparing on is whatever you've selected in this by column. So since right now we're comparing on total time, you'd also want to look at things like, did the count increase or did the average latency increase? That could be accounting for that increase in total time. And we only have a small increase here, but we can see it was actually ran a little bit less, but had a little bit higher average latency. All right, let me go ahead and remove that. All right, next, let's actually drill into a query. And so I've got a query selected here. So the first thing you can see is the digested view of the query. We often refer to it as a query family. And then down here, what you'll see is these individual circles. And what each individual circle is a sample that we captured. And if the circle is gray, that means there's no errors, no failed query rules, no warnings. If it's red, then it could be errors or failed query rules. If it's yellow, then it has warnings. And the three little dots indicates that we actually have an explain plan available. But one of the first things I actually look at, if I'm looking into a problem query or a potential problem query, is if I scroll down here, I look at this host breakdown. And I want to see, is this query being ran against multiple hosts? And as you can see here, right now we're doing the breakdown by count. And it's pretty evenly distributed, about 50% across both of these hosts. If I switch, though, to look by total time, now we can actually see that on MySQL 1, it's actually spending about 95% of the total time on that one host. Now, what that does is that indicates to me right away that there may not be any issue with the query itself. So trying to waste time figuring out, how can I rewrite it? Now I can go and look at, what's on this host, what's different about MySQL 1 versus MySQL 2. And there could be lots of things. The host could be sized differently, and that could be the cause. One host might just have resource saturation issues on it. Excuse me. With MySQL, one of the things that the most common reason I saw for disparity like this was on one of the hosts, the InnoDB statistics would get a little out of whack, and MySQL would start choosing a different index. So if we go and first, let's select. I'm going to start with the table explain view here. I'm going to select one of these lower samples because right now we're plotting them by time. And so then once I've selected the sample, I can actually then see what host it ran on, the database we're connected to, the user that ran it, the origin, the start time, as well as the latency for that actual sample or that time that query ran. And then over here, we can actually look at the explain plan because it has the three white dots there to see, what was the explain plan look like when this query was ran. And having this ability over time, having the ability to have multiple samples, multiple explain plans can be very valuable because if this was an incident or an issue where all of a sudden MySQL the optimizer was choosing a different index, what you would generally see is a bunch of low samples, and then when it changed, all of a sudden the samples would be higher. And you can easily see that on the graph. And then you can click and compare what was going on differently in the samples when they were faster versus when they're now slower. Is MySQL, in fact, choosing a different index? We actually had a customer chat into support with an issue similar to this. And it wasn't an issue with the InnoDB statistics, but what I was able to see was that, when it was fast, there was actual multiple possible keys, and it was choosing the best one. And then somebody accidentally dropped that index. And so then when the samples were a lot higher, what I could see was down here, that was no longer a possible index, and that's what accounted for the change in that query behavior. For this sample setup that I've created here, though, we can see when it's running fast, when it's running on MySQL 2, the rows examined is very low, around 4. If I click on one of these other samples, so now we're looking at MySQL 1, which, if you recall, that's the host that was actually having the performance issue. We can see that the rows examined here are much higher, over 105,000 estimated rows to be touched. But if we look at the JSON view, and let me scroll down on that, we can see that the used key parts, when it's going slow, is only this B column. And if I switch to one of the faster ones, we can actually see it's using A and B. So what I did to create this scenario was I have a composite key or covering index on both of these fields in both hosts. But on the MySQL 1 host, I've switched the ordinal position of that. And so in MySQL, that can be very important. And that's what's actually causing this slowness, because it's only being able to use the B column, which then it's looking at a lot more rows. All right, just scroll down to show you the rest of what you can see here. You can also see the same information you would see in the profiler with average latency, the total time, and the count, as well as additional metrics here, such as the row sent, the rows examined, etc. Right, next. All right. So far we've looked at queries by total time. As you can see, you can look at queries by a lot more things, such as errors. Errors are very important to look at to see, where are queries erroring out? Are you getting a lot of deadlocks, timeouts, etc.? And this makes it really easy for you to just jump in and see that right away. Another thing, actually, I'm going to jump over to a different environment to show you warnings. So another one, especially in MySQL, that's really important is identifying queries that have warnings. And as you can see here, we're seeing all these queries with warnings, and the yellow notification is also an indicator of that. And just to show you here, so if I go to this query, so now our samples are actually yellow. And so that's telling us that there's a warning. And if I scroll down here, we can actually see when we ran the explain plan that we got a warning back. And so we can actually see sometimes what is the actual warning. And as you can see here, it's not able to use the index actor last name due to a type or a collation difference. Surprisingly, this is very common. I see this usually in a customer's account at least once a week. And so it's a really quick way to figure out, how can you improve the query performance? It has the index, you think it would use the index, but it's not actually using it. And the reason for that, if I scroll up here, is for this particular one, it's a varchar field, and this number 1 is an integer. If I were to simply have quoted this, treating it as a string, then it would actually be able to use the index. All right. Next, let me show a couple more of these here. And these warning ones that I'm showing are actual things that we see very common in customers' accounts. So if I select this one here, we see it's showing an incorrect date time value, 1988 for last update. And if we scroll here a bit, if we look at the JSON view, we can actually see why is it saying 1988. And what MySQL is actually doing here is taking 2006 minus 2 minus 16. So it's doing the math on it. And the reason why it's doing that is because for this, I did not quote it. So this is not going to return the expected result set. Excuse me. Once again, this is actually a very common one that we see very frequently, similar to the last one, about once a week in customers' accounts. Lastly, so this one here, what you're seeing is, a truncated incorrect double value, 101 Main Street. And the reason is this is an integer field, and I'm trying to pass it as a string that has text. And so what MySQL is going to do is truncate all of the text, and it's just going to use the 101 value. And I actually just saw this in a customer's account yesterday, where it was very similar, where it was an integer field, an ID field, and they were accidentally passing an address in occasionally, not all the time. So what we saw was some gray samples and some yellow samples, and it was actually returning unexpected results just due to that. All right. Next, one of the really useful features in the profiler here is you also have the ability to see processes. What's actually processes are running on the database. So there again, if you have high CPU utilization, if you didn't find any new queries, you didn't see anything with compare, it's possible that there's some process that's using a lot of CPU. And so this would be a way that you might be able to spot that, if there was some big backup job that ran, etc. All right, next, I'm going to move over to our best practices section, and just to kind of show you across everything. So as you can see, there's lots of different best practices that we try to identify for. So for MongoDB, it's possible that we can detect where queries might benefit from an additional index. So this can be a really quick and easy way to get improvements on any sort of Mongo queries. We also look for configuration best practices. And this doesn't necessarily mean that, changing your configuration for the double write buffer is the right thing for your database. It's really just meant, all of these best practices are really just meant to kind of draw your attention to the way you're currently configured is not the same as what we generally see or what would generally be considered a best practice, is a way to get the customer to dig into that to make sure that their current configuration is intentional. And we give customers the ability to mute these if they're not. That way, they don't have all this noise in here. And then we also have recommendations on query rules, on best practices on ways to write queries. So here, this one with limit without an order by in MySQL can actually cause non-deterministic results. And actually, a few months ago, when I was showing a customer this, they actually said that they actually were having production issues due to that with their data. Some of the other ones can relate to performance issues. For MySQL, there's a total of 11 that we look for. One of the ones that's just not in this demo environment, but is very commonly found in customers' environments, is doing pagination with limit and offset. Which is actually can be really inefficient as your data set grows, especially as you look for higher offsets. And there's something called a bookmark scan that's actually much more efficient. All right, next, let's look at events. So we capture all sorts of different events. As you can see, we identify new important queries that could be a problem. For Postgres, long-running auto vacuums, index metrics aborted, etc. There's a lot more that aren't listed here. Not sure why I'm zoom out 30 days. I want to see if I can get the database configuration change to show up. Okay, so here it is. So you only see events based on if they happen within the selected time frame. So the reason why I zoomed out here was because I wanted to show this database configuration change event. And this is really a very important event. So we actually detect any sort of database configuration changes that happen. And, so to the early example about, being reactive, there's a problem on your database, identifying if there was a database configuration change that could have caused it. A couple of months ago, we actually had a customer chat into support, and they've been looking into a 3-hour time frame where on one particular host, CPU had, went from being very low to very high, and it was only for a few hours. And they'd been looking into it for a while before they reached out to support. And I first went through those first two things that I showed, looking to see was there a new query by looking at the first scene, doing some compares in the profiler. And then the third thing I actually checked was the database configuration change. And what I was able to see was on that host, when CPU spiked, somebody had turned on profiling on the database. And when CPU dropped, they had turned profiling off. And so that was a really easy way to identify that CPU increase was just due to the profiling being turned on, which is very CPU intensive within MySQL. Another great feature of our events are not only the events we automatically capture, which you can set alerts on, which I'll show in just a little bit, but also you can create custom events. And let me show you those, which are real easy to create. So the first thing to be able to create custom events is to have an API key, which is really easy. I'm just going to create a new one here. And it needs to be a read-write role because it needs to be able to write. So once I create that, it'll give me this token. And I'm just going to jump over here so I can work on it here. So the way this works is just the simple curl call. And right in our documentation, this is where I copied this out of. You can get it. So you just got to replace that with whatever your token is. There's a number of different things here. So the first thing is the start time. Now, obviously, this would probably be in your code deployment tooling. And you would automate this when we just grab a Unix ID here. So it shows up. So if every time code deployment happened, you could actually, have your code deployment tooling create this custom event, which would make it really easy, especially for your DBAs to know that there was actually a code deployment that might have caused that. So, and you can just call this whatever. So I'm just going to call it LMS code deployment. And let me give it a version 3.4. And then all I have to do is make that curl call. And then if I jump back over here into events, I now see my LMS code deployment, and my message was version 3.4. All right. Next, let's take a look at how easy it is to configure alerts. So the first thing to creating alerts is to have an integration. And currently we integrate with email, Slack, Opsgenie, VictorOps, PagerDuty, and Webhook. And then go back to alerts here. So as I mentioned before, you can create event or threshold-based alerts. I'm going to, for this demo, I'm just going to create a threshold-based alert. So the first thing I'm going to do is I'm just going to select a particular host to look at. And then you can alert on any of the tens of thousands of metrics that we capture. And just because I'm sure everybody's used to setting up alerts on CPU, I'll work with that here. So now what you can actually see down here is the actual data, the metric for this host, for this metric historically. And you can look at that by hour, by day, 7 days, or 30 days. And the reason why this is beneficial is if you've ever configured an alert during the daytime and thought, you know what, this is good, the way I've got it configured is great, and then at 2 in the morning you get woken up because something spiked because of a backup job or something like that. You don't want to get those false alerts, because every false alert, if you get too many false alerts, that starts to condition people to ignore them, which is a bad thing. The other side of that is, let's say you just had some sort of an incident and you didn't have an alert configured that would tell you, that something was going on before it became catastrophic. So this, if you set up the alert right after that, you'd be able to see, however you're configuring this, would I have been alerted when I expected to be? And so if I just put the value in here, and for this particular metric, this is microseconds. What you can see then down here is this alert threshold bar shows up. So I can see if I were to configure it like this, I'd get a lot of alerts. And so I obviously wouldn't configure it like this, but just for the demonstration purposes here, I'm going to leave it at that. Down here, we have a notify me frequency, and by default is to not silence repeated alerts. I'm going to select the silence repeated alerts for 1 hour, and because I'm looking at 1 hour. Next, I forgot to cover this. So this is how long does this have to be above the alert threshold? By default, it's going to be 1 second. One of the biggest configuration mistakes that we see is people will configure it to 5 minutes, and then it'll be above the alert threshold for 4 minutes, come below for a few seconds, and then go back up. And then you're not going to get alerted, because it would have to be above, that threshold for whatever you have selected there. So next is a recovery threshold. And if I bring that in here, so this really works in relation to the notify me frequency. So I've set to silence repeated alerts for 1 hour. Without actually, let me just first show this, setting it low. So if I were to have the recovery threshold rate like that, so it's below all of these dips, what's going to happen is I would get that alert initially, but then I would get, it would ignore all of these other times where it's going above the alert threshold. If, however, I had it set like this, now what's going to happen is I would get an alert immediately here, and then it would get ignored until it came below the recovery threshold and then back above the alert threshold. And then under that circumstance, then we would ignore the silence repeated alerts for 1 hour, and you'd get that second alert every time it went below the recovery threshold and then back above the alert threshold. And then once you have the alert configured the way you like, the next thing is to configure or to add to one or more integrations to have it sent to. You can create a severity level, and any of these alerts would also create an event, and that's where that kind of comes in. And then you can give a name for the alert as well as a description, and then create the alert. I think that's about it for me then.